Welcome back. We are now at Worksheet 8A. In the next preview assignment and in the next class, you will need to understand the concepts of the slope of a line and the Y-intercept of a line. I'm going to go ahead and underline those, that we're going to need to know the slope of a line and the Y-intercept of a line. These are going to be concepts that you need to make sure you're not foggy in your brain about. You've got to nail them down, what they are, how to find them, how to use them, how to write them in multiple ways. Beginning with the lesson talking about San Francisco, if you're driving up steep hills, and it can be measured using a slope. And then if you look at this 30-foot section of Bradford Street, it's not pictured, but it is very steep, and it's said to be at a 41% grade. That's crazy. Now is the time for you to hit pause. Go ahead and do questions 1, 2, and 3, and 1, 2, and 3, or just do question 1, and then come back and we'll work on it together. On question 1, the following graphs show lines with zero slope, positive slope, negative slope, and an undefined slope. Make sure you're wrapping your brain around that the lines that we're about to look at, one has zero slope, another what's called positive, another negative, and another called undefined. And somehow make these things make sense in your brain. Like I'm even going to start with the positive one. Because looking down in the bottom right corner, this from left to right, this line is going up, and we're going to call this one having a positive slope. Similarly, from left to right, this line is going down. So we're going to say it has a negative slope. So by process of elimination, we're now down to looking at which one's zero and which one is undefined. Maybe you want to think about riding a bicycle, because if you were riding a bicycle along this slope from left to right, you've got no hills, no ups, no downs, zero. Nothing is going up or down. It's a zero slope. However, if you wanted to put your bicycle on this line, you might have issue. You won't be able to ride up that line, and therefore, and for some other reasons, we'll say that this one is called an undefined slope. You might make flashcards for these, a Google document, something along the lines to nail down in your brain. These are some different types of slopes. Slope is abbreviated with the letter M. It's sometimes defined as a ratio or a fraction of the up and down movement. You've probably heard rise over run. So it's up and down, which indicates the rise, and side to side, which is the run. Here's a fraction of that where the slope is rise over run. You may have seen other ways to describe slope, like delta meaning change in the y, which again is the up and down, over change in x, which is the running, the left and the right. And then they give us an example. For example, the Bradford Street has a slope of 41%. In other words, it rises, so its slope rises 41 inches for every 100 horizontal inches. In other words, it's about 12.3 feet that it goes up along a 30-foot distance. Again, if you haven't hit pause, go ahead and hit pause to do at least question number 2, and I'll see you back here on number 2 to talk through this together. But question number 2 says, find the numerical value. We want a number. So when we get done, we're going to say the M of this one is, and the M of this one is, etc. I'm going to go ahead and start with the ones at the bottom. And you probably have had or remember been exposed to. And by the way, this is a good time to mention that in my math lab, inside your in-class student pages to print, in the packet, there are resources, and there is a resource on slope. So that's one place to get some additional information. Don't forget about tutoring. Don't forget about doing searches on the internet. And don't forget about talking this over with fellow students. They have great ideas on how they see these concepts. They can really help you to learn them and to learn them well and not just sort of know them. So looking at this slope idea, there is a formula. And we've seen the formula before, maybe, or remember pieces and parts of it. So there is a formula, but I'm not going to choose to do the formula on this one today. They want a numerical value. So I'm going to find two dots that I can definitely see where they are. And then I'm going to follow the rising and the running that they mentioned, that was mentioned earlier. So like from this first dot, I'm going to go down 2 dots. In other words, I'm going down 2 spaces. So my vertical change is down 2. That's negative. To get to the final dot, I need to go in the positive direction 2 spaces. And when I get finished and reduce and make this all pretty, I have a slope of a -1. And a while ago, we said if it's going down left to right, it's going to have a negative slope, and voila, it does. Let's do the same kind of process on this line. Again, you can go ahead and go through the formula. You can do various and sundry things. Just make sure that whatever you're doing is accurate every time that you do it. So on here, I'm going to find there's a place and there's a dot. So to get from one dot to the other, and it doesn't matter which way I go, I just need to be consistent with how I write the information down. I'm going to go ahead and start with this dot, and I need to put the vertical change in the numerator. So for this dot, I need to go up 2 spaces. And once I go up 2 spaces, then I'm going to go back 1, 2, 3, 4, or, oh, that's not back. That's the positive direction of 4 spaces. When I reduce this fraction, I get a half or a positive 1/2. And earlier we talked about if the slope or the line is going left, right, up, we're going to call it positive. So here's the numerical value, here's the numerical value. And remember, you can start and stop this video as often as you'd like. And you can email me and ask, did you mess up? Or what did this mean? Or I don't understand. A lot of communication is going to help your understanding of all of these concepts. So I'm going to keep doing what I was doing just a second ago. I'm going to find 2 dots. So I'll find a dot here, and why not the dot there? And remember, the vertical goes in the numerator. So when I'm looking for vertical change, how much up or down do I go? Well, I don't. And then the points I've chosen, I'm going to go to the left, to the right 4 spaces. It really doesn't matter what I put in the denominator, because with no vertical change in the numerator, it's just going to be 0. So a horizontal line is going to have a 0 slope every time. No calculation needed. Let's look at this vertical line. I'm going to do the same kind of idea. Here's a dot. Here's a dot. Remember, I'm doing vertical over horizontal, rise over run. So from my dots, let's see, I go up 1, 2, 3, 4. So I went up 4. And then how much do I change left or right? Well, none. And then the alarms start going off that when you try to divide by 0, it is undefined. It ain't happening. And so any vertical line will have a slope that if they ask you what's the numerical value, you say the numerical value is, it's undefined. Remember in this lesson, we are going, sorry about that, undo. In this lesson, undo a little bit more. There we go. In this lesson, we're going to talk about slope and y-intercept. We're finished talking about slope, let's move on to y-intercept. When we describe the graph of a line on a coordinate grid, the place where, and when you're talking about a flashcard or glossary, when you're asking yourself, what is the y-intercept of a line? It is the place where the line crosses the y-axis or the vertical axis. That's what you call the y-intercept. It runs through it. It crosses it right there on the y-axis. As with all points on a coordinate grid, the intercept is described using an ordered pair of the form xy. All points get this xy, but the y-intercept gets a special set of points because we call the y-intercept b. And if we're going to call it b, and every time it hits the y-axis, it's right there at 0 on the x-axis, it's always going to be 0, and it's always going to be the number where we crossed the y-intercept. A whole lot of information right here. You really need to write it down somewhere and be memorizing it. So then the picture shows the line below has a y-intercept at 0, 4. It's right there. So a couple of things. We can say that the intercept is happening at the coordinate 0, 4, or we can just declare the y-intercept is 4. It's a couple of ways we talk about y-intercept. Question 3 puts it all together real fast. They want to know what are the slope and the y-intercept. Well, since we were just talking about y-intercept, let's go ahead and start with that one. Right here, and hopefully yours is a little bit more clear, but right there is our b. Our b is at 1. And if somebody said, hey, what's the coordinate of your y-intercept? It's always, always, always 0, and then the number of where we cross the y-axis. The next piece says, okay, then what's the slope of this line? A while ago, I looked at the change in the vertical over the change in the horizontal. So let's go ahead and use our y-intercept and that point right there. From the y-intercept, I need to go down 1 space, and then I'm going to go to the right 4 spaces. And I'm done, because my slope is going to be negative 1/4. So to answer the questions, y-intercept is 1, the slope is 1/4. And they don't tell us how to write these. They don't say to write it using just b is worth this, or that the y-intercept's that coordinate. You just need to know both. You need to know how to write, read, and find both. Moving on, we've got a few more to do. Again, if you haven't hit pause, or if you weren't really sure how to do question 3, and now you're understanding it better with part A, hit pause. Go do parts B, C, and D, and then come back. So B is asking for the same information. Let's go ahead and find what I think might be the nicest one to begin with. We'll start with the y-intercept, which is down at -5. That's a good enough answer. It's complete. If someone says, what's the coordinate? It always, 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 always starts with 0, and then you put where you cross the y-axis. We're going to keep going and find the slope. Remember, it's rise over run, the change in vertical over the change in horizontal. And I'm going to go ahead and use that dot right there. I need to go up 5 spaces. That's a positive direction. Then I need to go to the right 5 spaces, and when I reduce, I get a positive 1. So my slope is 1, and my y-intercept, whichever one of those that you want to write to be the y-intercept. Looking back at parts A and B, A had a negative slope, B had a positive slope, and it just lends to believe that the next two, one's going to have a 0 slope and one's going to have an undefined slope. Remember what we are looking for. They're asking us to find or identify the y-intercept, and they're asking us to identify the slope. You need to put it very large in your notes that every horizontal line, period, end of story, is going to have a slope of 0. No counting needed, nothing needed to be done. The slope is 0. The y-intercept is going to be wherever we're going through the y-axis. Looks like we're going through at 3. We're done. Unless you're not really liking to leave your slope or your y-intercept as a b equals 3, then you can always write it as a coordinate. We'll finish this lesson by looking at part D. And on part D, with it being a vertical line, go straight for the answer. The slope of a vertical line always, 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 always is undefined. B is where we go through the y-axis. Where am I going through the y-axis? I'm not. And so in this particular case, the vertical line that we're talking about, its slope is definitely undefined, but we can put something like does not exist. It doesn't exist. There is no y-intercept. You can just write down there is no y-intercept. And these are okay answers. They're very accurate, and they're what we need to say, that there's no y-intercept and the slope is undefined. This concludes lesson 8A. Check your calendar to see if you have more videos to watch for this week before this week's deadline. And I'll either see you again this week or I'll see you when you start prepping for next week. Bye-bye.